Hello everyone, welcome to Team 13's presentation of the project for ME452 Design for Manufacturing. Our team members include Guru Prasad Srikrishnan, Raghav Tripathi, Saranj Goel, Vishnuvardhan Iyengar, Vijay Venkatesh and Rajkumar Thomas. In this project, we have decided to analyze and subsequently provide a feasible redesign of a gear pump. To give you an idea of what a gear pump is, it is a device that is used to displace or move fluids from one place to another with different pressures and speeds. It contains multiple gears meshed together in a body called the housing, wherein the fluid enters the pump through an inlet and then fills the gap between the teeth of the gears. The fluid is moved around due to the rotation of the gears. The gears on the outlet region then force out the fluid at the required pressure. The picture that you see here on the slide is a model of a gear pump that is primarily used for displacing oil, which is a fluid of generally higher viscosity. The size of the gears as well as the inlet and outlet can be changed in order to accommodate other types of fluids. According to the data we have collected from various online sources, we have found that an estimated 9 million units of gear pumps are produced by various industries and companies, with the entire industry worth about $9.1 million as of 2023. This growth is expected to reach to about $12.8 million within the next 10 years. Further, our primary customers would include oil and gas industries for which the fluids are more viscous than water and as a result would require relatively more variation in fluid flow. On the other hand, our secondary customers include water treatment plants, chemical plants, and some other names that you can see on your screen. These mostly include fluids that have similar viscosity to water. This would require a slightly different setup in the gear pump.
In this slide, you can see the list of components that we have used in our project, as well as the exploded view of a product. In the controller of the pump, we have the control module for the motors and other electronic parts. Here, we are showing you the fast diagram of the gear pump. This includes the various functions that the gear pump must execute in order to successfully move the fluid to the correct place. The task function of the pump is to transport fluids, which is done by two major primary functions, which is drawing the fluid and regulating the pressure. We have other secondary functions like to assure dependability, we do eliminating leakage and etc. as shown in the diagram.
In this project, we have decided to go with two different assembly sequences. In this slide, the fishbone diagram of the first sequence is shown. In this sequence, we have made housing 3 as our main assembly line, and the other components such as sub-assemblies are assembled onto it. Moving on to the optimized second assembly sequence, we are changing the main assembly line to housing 1 because it is the largest part and all the other components are being attached to it. As a result of these changes, the number of assembly steps to the main assembly line have been reduced.
By placing the two sequences side by side and scoring them on the 5 criteria as follows, we have found that the second sequence gives us a higher overall score, and as a result is easier and more convenient to follow. Further, the second assembly provides better handling, makes it easier to locate, and also allows for parallel assembly.
In front of you is the function component mapping matrix where we have matched all the different components of our product with the functions that were previously mentioned in the first diagram. Many of the components perform multiple functions, but the most relevant function is to contain the fluid that is transferred through the gear pump. This is our product's bill of materials. The production rate we assumed was 150,000 units per year. We gathered data from online sources such as hubs.com and custompart.net. We assume the nationwide average labor cost of $20 per hour and the assembly will be done manual. The total cost of manufacturing a part just comes to be around $14.4. In this slide, we are showing you the quad chart containing the classification of parts based on their functionalities and their cost. So from this, it is obvious that the parts having a higher assembly cost and a good functional importance would require a redesign so that the cost is reduced while they can perform the same function.
Based on the product family diagrams, we are required to cater to different customer groups. In this regard, the main functions that we would need to modify are controlling the flow and operating the motor. And these functions directly correspond to the modules as follows: pulley, shaft, housing 2, as well as the housing for subassembly.
Now we are looking at the two variants of the design for the two segment groups. The one on the left can be used for fluids of higher viscosity, primarily oil. The one on the right can be used for fluids of relatively lower viscosity such as water or beverage processing. 4 changes have been introduced in catering to the secondary customer needs. First, the V-belt pulley is made wider. Second, the thickness of housing 2 and housing 4 have been reduced. And finally, the shaft has been made hollow. Here, we have the product family assembly sequences. As you can see, The second sequence has more parts that do not need to be modified for the two customer groups, and as a result, the sequence is more optimized. This provides a shorter assembly time and delayed differentiation as well. Thank you.